of all the metals, of all the elements group 3. So therefore, if you study group 3, period 3, those elements in period 3, if you study them well, their physical and properties well, you have studied the physical properties of all the elements in the periodic table. Hence, therefore, elements in period 3 are called typical or representative elements. Why representative? Because they represent all the elements in the periodic table. Have you followed this? Is this clear all of you? Now, when the metals, that is, metals meaning your periodic table, those that are elements on the left hand side, and elements on the right hand side are non-metals. So, if the elements on the left hand side, do they accept electrons or do they donate electrons? They donate. I just said, I did not say they are metals. I just said they are elements on the left hand side. Do they donate or do they accept? Donate. They donate. If they donate, what do they become?
They become a positively charged ion.
What is one property? They become positively charged ion because they've given out the electron. What is the next property that they become metals? Third one?
They have a covalent.
They are
crystalline.
They are good reducing agents.
They are good reducing agents.
They're good reducing agents. If they're good reducing agents, what happens to them when they donate an electron? With reference to this, they are good reducing agents. So, what happens when they donate an electron?
They are reducing agents. They get oxidized.
They get oxidized. If they donate an electron, they get oxidized. If they get oxidized, they are good reducing agents. I told you good reducing agents get oxidized. Follow? Good reducing agents get oxidized. Follow? So then these metals are oxidized. Why are they getting oxidized? Because they donate an electron. And because they get oxidized, they are good reducing. But if they are oxidized, they have got oxygen in them. If they've got oxygen in them, then they become good reducing agents. They can take out that oxygen. They can take out that oxygen. Reducing agents take out the oxygen. Okay? So what is responsible for the chemical, the similarity in the chemical properties of an element? What in a particular, what is responsible for the chemical and physical properties of an element in the periodic table? The similarity in the number of electrons in the valency shell, correct? Okay. Now pay attention. If the element releases electrons very, very fast or accepts electrons very, very fast, the chemical reactivity is very, very high. When will I say that a particular metal or a particular element is highly reactive? What does the chemical reactivity of an element depend upon? It depends upon the speed of donating or accepting electrons. For example, I tell you, sodium has got 1 electron in the outermost shell. Aluminium has got how many electrons in the outermost shell? Yes, 3. How do you know it's 3? Because it's in third A group. What period is this? Group is this. So what? It is in third. It is in third group. All right. Now, okay. But I am telling you that sodium is more reactive than aluminium. Sodium has got only 1 electron. Aluminium has got 3 electrons. Yet I am saying that sodium is more reactive than aluminium. Why?
It is easier to give away 1 electron faster than to give away 3
electrons. Because first of all, sodium atom is that large. And it's got only 1 electron in the outermost shell. Aluminium, the orbit is large or small?
Small.
It's small. So don't you think it's difficult to take out 3 electrons from here? It's very easy to take out something from an open tin. Very difficult to take out something more, and that is from a closed. Okay, so that's why sodium is more reactive than aluminium. So chemical reactivity does not depend upon how many electrons you give, but how fast you give it. I give you the example of a rich person and a poor person. Yes or no? Do you remember? Of course, you will not remember, but I told this story to you centuries ago. Huh? What did I say?
Like the poor person always invites other people to eat even food, so he makes more relations. While the rich person always stays in his house. So he
No, I didn't say delicious food. What I say this, suppose there is a rich person like me. Suppose a rich person like me. And suppose there is a poor person like him. Only suppose. Yet being a poor person, he has kept his doors wide open. And he has told people, come, here my house is open. The house is open because there's nothing to rob. But that's a different story. He is the type, despite the little that he has, he wants to share with everybody. I, despite having so much, I don't want to share with anybody. I have shut my doors. I, me, myself. My money is for myself, for myself. So who do you think is going to be more reactive? I or he? He. Despite the fact, so your reactivity doesn't depend upon how much you have got. It depends how you relate to people. I may have a lot, but I'm not relating to anybody, so I'm very, very unreactive. Is this clear? Is this clear now? That's why sodium is more reactive than aluminium because sodium has to give 1 electron, aluminium has to give 3 electrons. Sodium's shell is very, very large, but aluminium shell is small, tighter. So it's difficult to take out something from a tight or a closed tin, correct? Now, what are isotopes and what are isobars? Isotopes and isobars. Yeah,
Isotopes, I think, are the ones with the same atomic number and different valencies.
different and valency.
No, variable valency.
No.
Mass. Because they have different mass number.
They have different atomic number, the atomic weight.
Weight, yeah.
They have the same. Now pay attention to this. Isotopes have got the same atomic number, but different atomic mass. That means atomic weight is different. Atomic weight is different. I compare isotopes to what? In a day-to-day example, I told you when I explained to you isotopes, I compared them to somebody, to twins. They have the same mother, but their weights are different. One is a fat twin, one is a thin twin. Okay, so if they have the same atomic number, what idea do you get? It's the same atomic number means what?
Their chemical properties are same.
That will be okay, yeah, that will be, they're not great.
They are same element.
It's the same element. It's the same mother. Chlorine has got isotope 35 and 37. One is thin chlorine and one is fat chlorine. Both of them are chlorine. So isotopes are
Hydrogen.
hydrogen also. Hydrogen is a one gas. You have got deuterium,
Tritium, deuterium,
protium, deuterium and tritium.
Ma'am, we had a similar kind of question.
Ah.
I have a question.
Okay. So did you answer it? That's very important. Having the question paper one part of it, did you answer correctly? Is another
Yeah, I
part.
got
Okay,
it.
good,
It was an MC.
very good, huh?
It was an
MCQ, okay. So therefore, this is what happens. If it's an isotope, the element is the same. Weight is different. If it's an isobar, what is an isobar? Yeah.
They have the different atomic number but same atomic mass.
They have different atomic number, but their mass is the same. The mass is the same, but the atomic number is different. If the atomic number is different means there are two different elements. Two different elements having the same atomic weight.
Argon and calcium.
Argon and calcium. Okay, that's what they said. For example, in the case of the iron, they said I can't say all those who are weighing 47 kilos stand up, 10, 15 of you will stand up. Correct? But if I say roll number 47, only one child will stand up. So number is a defining property. So isobars you know, isotopes you know. Have you learned the properties of isobars and learned the properties of isotopes? Okay, open up your book and read till there, then I want to go to the next part of it. Yeah. Read till there. What are you going to read? You have to read valency. From valency, right up to isobars. From valency, read. The book is closed. Bye. How many marks you got in chemistry in school? And in maths? Geography? English? Huh?
Literature 60.
60 on literature. And language? You? In English?
In literature, I would 77.
On 80. And language?
Language not
Chemistry? Maths?
77.
On 80. From valency right up to isobars, and please read. You have to write down as a note. Write down as a note. How many of you don't have isobars in your books?
It's not in the syllabus.
It is there in the textbook.
It's there in the textbook, but it's not in the syllabus. It's not in the graph plan. Right?
But it's nothing wrong if you learn something about isobars. So write down isobars are, take down those who don't have isobars in their book. Write down isobars are, in the textbook only you can write down. Atoms of different elements. Isobars are atoms of, write down in the textbook itself. Isobars are atoms of different elements It is not there in your book, write it down. Only Selena has it. Have you got Selena?
Yeah, I got used to it. I forgot
Isobars are atoms of different elements with the same mass number, with the same mass number, with the same mass. Write it down in your textbook, not in that exercise book. That exercise book will go to the Kachadama and that knowledge also is gone there. Give that donkey a pencil. Isobars are atoms of different elements, with the same mass number but different atomic number. Isobars are atoms of different elements having the same mass number but different atomic number. Okay? Example. So therefore they have different physical and chemical properties. Different physical and chemical properties. So therefore they have different physical and chemical properties. They have different physical and chemical properties. They have different physical and chemical properties. Why do they have different physical and chemical properties, Ian? Why do they have different physical and chemical properties?
So it doesn't have to be number.
because they are for different atomic numbers. In other words, they're two different elements. Correct. Absolutely correct. Okay. All right. Now, example. Again, put 40 on top and 18 below. 18 is what now? Atomic number. 18 is atomic number and top is 20, which is atomic mass. 40. And calcium, again 40 on top and 20 below. 40 on top and 20 below. And second example is chromium. 54 on top and 24 down. 54 on top and 24 below. Is it there in the volume?
No. I've got Selena.
You have got Selena. And Fe, iron. 54 on top and 26 below. 54 on top and 26 below, correct? Okay? Have you got that now, all of you? Now, what is meant by electrovalent bond? How is it formed? In what is an electrovalent bond? How is it formed?
When an electron that gives the number of electrons in another element complete its balancing.
No. I can't understand the word. Did you understand what he said? What is an or how or when is an electrovalent bond formed?
Two elements share an electron.
When two elements share electrons, wrong. Yes,
Transfer of electrons from a metal to a non-metal.
yes. Okay, so therefore it is electrovalent, or what is another name for electrovalent?
Ionic.
Why is it called electrovalent to ionic bond?
Because electrons are being transferred.
No, it's because metal has got positive and non-metal is negative. So both the charges are there. Electricity is there. Why? Because two different charges are there. Two different charges are there. Positive coming from metal, negative coming from non-metal. Therefore, it's called electro. Electro means electricity. Okay. Now, all right. Then, so therefore, we will say, I'll ask you, give me the definition of an electrovalent compound. What is an electrovalent compound? Okay.
Potassium.
I didn't ask you for an example. Pay attention to my question. I didn't say give me an example. I asked you give me the definition of an electrovalent compound.
I'm not sure, but
Say,
when a metal and non-metal form,
when a metal and non-metal is formed,
no, not form, but when it's
yeah,
When a metal gives an electron to a non-metal to form a compound.
to form a compound. And there was the next part of it. Next, and any other definition? Yeah. You have to say an electrovalent compound is a compound containing the electrovalent bond or ionic bond, which is formed by the donation of electron from the metal and the acceptance of that electron by the non-metal. Hence, an electrovalent compound will always have a metal and a non-metal element present in it. These are the 3 points for the definition of an electrovalent compound. An electrovalent compound is a compound that has the electrovalent bond, which is formed by the donation of electrons from the metal and the acceptance of that electron by the non-metal. Okay? And an electrovalent compound will always have a metal and a non-metal element present in it. Have you all understood this? This is the definition and the properties of an electrovalent compound. Okay? Therefore, what will be the definition of a covalent compound?
Covalent compound is formed when electrons are being shared between two non-metallic atoms.
What else?
There is no charge separation.
There is no
Charge. No, there is a charge separation in polar bonds.
polar bond. Have you learned polar bonds? So what is a covalent compound?
Covalent compound is a compound that has covalent bonds in which electrons are being shared by two non-metallic elements.
Hence, therefore, a covalent compound contains two non-metals. If this contains a metal and a non-metal, this will contain two non-metals. That's the same points that you use differently. What is a covalent compound? A covalent compound is a compound having a covalent bond, which is formed by the sharing of electrons between two non-metals. Hence, therefore, a covalent compound will have two non-metals. This is clear?
Can we say that covalent bonds are stronger than ionic bonds?
Covalent bonds are not always stronger. If they are polar, if they are polar covalent bonds, then they are stronger because polar covalent bonds act like ionic bonds. Ionic bonds are very strong. They are very, very strong. And if it's polar covalent bond, then they behave like ionic because they have a charge. So they become very, very strong. But as such, two non-metals, they are very, the covalent bond is not very, very strong. Okay. See, simple definition is both of them are sharing electrons. So both the charges are the same. Like charges don't attract each other; they will repel. So the distance between both these elements is quite far away. The further the distance, weaker the bond. Have you understood? Further the distance, weaker the bond. But in the case of metal and non-metal, one is positive, one is negative, so they are attracting each other. So if they are attracting each other, they're coming very close to each other. So the bond is very, very strong. Shorter the bond, stronger is the bond. Followed? Now, who will draw the structure of magnesium chloride on the board?
Magnesium.
Chloride on the board.
Electron
right,
dot structure.
right.
The dot structure is well.
Everything. Is it electrovalent or a covalent bond?
Magnesium chloride. Ionic bond.
Why?
Because it's sharing, it's giving out the electrons from the non-metal.
From?
A metal to a non-metal.
Which is the metal here?
The metal is magnesium and non-metal is steel. There's no pen. Shall I ask?
One. Did you redo that composition last time? Did you redo it?
Yeah, but little bit is.
Okay, waiting for whom to complete it tomorrow?
I know I'll complete it.
I have finished the treasure chest. I have finished treasure trove, no, completely with your, and Julius Caesar also have completed. Yeah, okay. Sorry. I think that's such a light pen. Go and take a dark pen. Take another pen. You go and do KBR on the board. On this side of the board, you do KBR. Get a nice pen, a strong dark pen. You go in and take it.
KBR is not.
Huh?
KBR is not.
KBR is?
I know.
I didn't understand it.
KBR is not.
How many electrons bromines?
Bromine. Then I don't know.
We only like have to make them up to 20.
Up to 20. So,
After 20, we do not have.
so KBR is what then?
Bromine is below after 20.
Arey, you are such a foolish person. You just see what this. We're talking about electronic configuration now. Show the one, show the formation of KBR on the board. What's the problem?
I guess the atomic number of magnesium is 11, right?
Huh?
12.
It's perfect.
Correct?
Ooh, wrong.
Wrong?
No, 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 no.
What is the formula of magnesium chloride?
Huh?
Cl, 2 Cl bond.
Oh yeah, sorry. So one electron goes there and one electron, but it
Yeah, but what, how many are there in the outermost shell?
there are 6 in that.
What rubbish? Look at your configuration. Look at the configuration which you put it right on top.
It's for magnesium.
Yeah, okay, for chlorine. There's the configuration of chlorine.
Okay, wrong?
Chlorine is 17, you foolish girl.
17. Okay, sorry.
7.
Shall I draw the after combination here?
Not necessary. It's okay.
It's okay?
Okay. Actually, you're supposed to be putting it into the final big box bracket if they use.
Yeah, you have to use here at the column and the power, the positive and the negative as well.
Do it.
Shall I do the dot structure instead? Here.
Actually 19.
What you wrote there, what you did is 17. 2, 8, population of
19.7 bro.
Actually was
19
19.
अच्छा 19
I was at
17.
पहले आखिर वाला 8
17.
इसके बीच वाला 80 होता है बीच वाला 52 है तो ये 86 क्या बोले is it 287
8, 18, 7.
electronic configuration
And bromine is what now?
2, 8, 18, 7.
Ah,
2887
and 7.
No.
The M and the you have to go to you should you would take that.
Correct?
Yeah, but then you make a final thing MgCl, 2Cl,
Yeah.
and put in the box bracket.
This only Cl or the
Yeah,
whole thing?
like that. Whole thing, whole molecule. Okay. You come for chlorine now. You take a little bit of box bracket only for chlorine, don't take a for Hg. Two is meant for chlorine, yeah. Because it, yeah, yeah. Okay. And yeah, what have you done that stupid boy done it?
Leave it like that. Don't draw it.
That's wrong.
Ma'am, alright now.
Yeah.
Abhi ये
Okay, what is that? Come this side. Arey, that becomes sharing. When you're showing set theory like that, it is sharing. That is wrong figure. That above finger is correct. There is donating. The second figure below, that is wrong. That is wrong. That's for sharing. That's for covalent bond. And set theory is for covalent bond. Idiot. Come on. Now listen, pay attention. Now we answer the questions orally. Close all your books. Close all your books. Yeah. Rutherford's alpha particle scattering element experiment led to the discovery of what? Electron, atomic nucleus, proton or neutrons? Rutherford.
Which experiment? What experiment?
Rutherford's experiment. Rutherford alpha particle experiment.
Atomic.
Alpha particle. No. Protons. Alpha the protons. Positive. Next one. The number of valence electrons in oxygen ion. Wait. The number of electrons, valence electrons in oxygen ion is how much?
6.
8. Oxygen atom is 6. Ion is 8. Because it's accepted. When it accepted 2 electrons, it becomes an ion. So for stability, 6 became 8. Then, which of the following is the correct electronic configuration of potassium? This one will not have to put on the board. Okay. Mass number of an atom whose unipositive ion has 10 electrons and 12 neutrons is what? Ian. The mass number of an atom whose unipositive ion. Uni means 1. So sodium positive, 1 positive, not plus 2 but plus 1. Has 10 electrons and 12 neutrons. Huh? What is that? You're supposed to find out the mass number. Mass number is what? Huh? Mass number, 30, yeah, 30. No, 10 and 12? 10 and 12 only it is. 22. You, this girl. The number of valence electrons in chlorine ion is how much? Chlorine ion.
320.
Huh?
In the iron it's 20.
Chlorine.
Oh, no. It is 2 8, 7. So let's
So what's the answer?
I think it's
18. 18. You're asking or telling me 18? You. The correct electronic configuration of fluorine is, now you want to do it, okay. An element A has 15 electrons and 16 neutrons. 15 electrons, 16 neutrons. What will be the atomic weight? What is the atomic weight? Huh? The element has 15 electrons and 16 neutrons. What is the atomic weight? You? You? Anyone? Huh? Are Gadas? Element A has 15 electrons. So you have 15 electrons, will have 15 protons.
Yeah.
Okay? So therefore, and 16 neutrons. Neutrons are the nucleon. 31. Correct. Who said 31? All of you. Okay. So what will be the correct representation? How will you represent this?
31 and then 16.
31 on top
Yeah.
and 16 below.
And between
Huh?
15.
15 below. 31 above and 15 below. An atom has 3 protons, 4 neutrons. What will be its valency? 3 protons. Yeah. Elements with valency 2 are metals, non-metals. They can be metals or non-metals. They are metalloids. You,
They can be both
metals and
non-metal.
how can they be non-metals?
And non-metals,
Valency 2.
their valency is 2, right? So the valency can be both negative and positive.
Array, when it is 2, it's understood that positive sign is that we don't put plus 2, it's understood positive.
Metals.
Khada. If it is just 2, the plus sign is understood. Yeah, that boy there. Nucleus of an atom is composed of electrons and neutrons, protons and neutrons, protons, neutrons and electrons, electrons and protons, protons and neutrons. There are 3 electrons in M shell of an atom. Its atomic number is
3 electrons in
M shell.
and neutrons is
You don't ask any further question. What I've given you, that only you relate to that much only I've given you.
27.
The max, there are 3 electrons in the M shell of an atom. Its atomic number is what?
Atomic number is 13.
13. 2, 8 and 3. The maximum number of electrons that M shell can occupy is 18. Which orbit is the nearest to the nucleus of an atom? K, L, M, or N? Where the hell are you?
The nearest
Keep scratching your hand or flinging out of your hair. Atomic atoms combine to attain an electronic configuration similar to their nearest metal, non-metal, noble gas, or semi-metals. Isotopes differ in the number of their electrons, protons, neutrons, electrons, and protons. Isotopes, they differ in their electrons, in their neutrons, in their protons, or their electrons and protons. They differ. They differ, no? So they will differ in their protons and neutrons, protons and electrons give you atomic weight. Protons, so there is no protons and neutrons. The next word is electrons, protons, neutrons, and electrons and protons. Neutrons. Name the following. The element which does not contain any neutron in its nucleus. Protein. Which hydrogen? Protein of hydrogen. So proton. Proton. It contains protons. It doesn't contain any neutron. An element having valency 0. Valency 0. I think yes. Any inert gas. Helium, yes. Metal with valency 2.
All the metals in the group 2.
Very correct. Very smart. Too smart is. One metal. I said metal. I didn't say metals. You donkey. Metal. All the metals are group 2. So smart he is. Give me one metal. He doesn't know the names of the metals in group 2. So smart. You think you're too chalu, no? So you think I'm an idiot here? Give me the name of one metal. Are donkey?
Magnesium.
Look at the board. Too smart he is, you know. Two atoms having the same number of protons and electrons, but different number of neutrons. Are give me the name. Give me two atoms.
Protium, deuterium.
Two atoms having the same number of protons and electrons, but different number of neutrons. So,
Protium, deuterium.
if they have the same number of protons and electrons, two atoms having the atomic number is the same, no? So they're the same element, you idiot. They're the same element, isn't it? So chlorine.
I was giving hydrogen. So
Hydrogen, you say. Hydrogen 1 and hydrogen 2. You don't go in for that. You go in for something like chlorine. Simple. The shell closest to the nucleus of an atom.
Cage.
Cage. Too easy. Then, okay. In what respect do the three isotopes of hydrogen differ? In what? By the atomic
Mass.
how? Now explain to me. Explain how it is different. Atomic mass, yes. Then, which are the three? They say three, no? Which are the three isotopes and how? Contains how many neutrons? Protein. Protein doesn't contain any neutrons. It contains only proton. Protein means proton, you idiot. 0. Then deuterium is 2. That means it's one proton and one. And then tritium. One proton and 2 neutrons. I have answered it for you.
I said, you can answer. Then you second if you answer.
So that's smart.
You can ask him.
He's an idiot like you.
You got 77.
So what is your 77?
It's smart. You can't do it.
I get it from here. That's the life out of you, okay? Yes. What is the significance of the number of protons found in the atoms of different elements? Significance.
with the chemical properties.
What is the simplest? The number of protons found in the atoms of different elements.
It shows the atomic mass, atomic number of the element,
Yeah.
protons, and it determines the chemical properties.
Protons don't. Even if one is built up by the electrons, protons cannot be connected with the L-type directly. So that's wrong. Then we
It's
have
it gives the mass to the
it gives mass to the neutrons. Nucleus.
nucleus.
Element X has electronic configuration 2, 8, 18, 8, and 1. No. An atom of an element has 2 electrons in this M shell. It has got 2 electrons in the M shell. What is the atomic number? What is the number of protons in this element?
The atomic number will be 12. What was the next question?
Number of protons in this element.
12.
Same.
Yeah. Is that any other question?
Why do chlorine 35 and 17 and chlorine 37 and 17 have the same chemical properties? In what respect do these atoms differ? Why do chlorine 35, 17 and chlorine 37, 17 have the same chemical properties? Why do they have the same chemical properties? In what respect do these atoms differ?
They have same chemical properties, so these chemical properties are dependent on the atomic number, and they differ in the number of neutrons.
And they differ in what respect do these atoms differ? They differ in number of neutrons. They are the same element, you have to say. You said that they have the same atomic number. Correct. They are the same element with different weights. That's important.
Now, can I switch on this please?
Yeah, put up there, please. Physical properties of isotopes are different.
Isotopes.
Because they have different atomic weights.
They have different atomic weights. So the physical properties will differ. Correct? Okay. Atomic mass is greater than a mass number. Atomic mass is greater than mass number. Atomic mass is greater than mass number. Why? Is it true or false? Whatever is your statement, back it up. Is the atomic mass greater than mass number? False. True. Why?
Because it is an approximation, the mass of the neutron and atom and the electrons are not counted. So
Yeah, so you have to say mass number is atomic mass number which contains only protons or electrons. But atomic mass contains neutrons also. Protons and neutrons. Atomic mass, that's atomic weight, contains protons and neutrons. It's the entire weight of the nucleus. But mass, atomic number, contains only protons.
no atomic mass, no. Mass would contain both.
I said mass, atomic mass is what? Atomic weight. What does it contain?
Atomic
Weight of the nucleus, no? What is in the nucleus? Protons and what is mass number?
mass number of neutrons and protons. Atomic weight would have the electrons also included.
Atomic mass number is atomic number. Mass number actually means the atomic number, which contains only protons or electrons. You're getting confused. What is atomic number? What is atomic number?
Atomic number of protons.
Or electrons? What is atomic mass number? Mass number is what?
Number of protons and neutrons.
That's the rate of the nucleus. Instead of feeling sleepy, or his brain is getting fried.
Right.
It's okay, it's almost done.
She does that everything. No, he really does
संदेह क्वेश्चन नहीं था संडे को टेस्ट